In this lesson, we're going to learn how to balance chemical equations, and we're going to try to understand why we need to do so. Why do we need to balance equations? It's in order to respect the law of conservation of matter. Sometimes this is called the law of conservation of mass, but it's the same thing. So in order to respect this law, we must use what are called coefficients. Coefficients that are in front of each chemical formula in a chemical equation. We do this so that the number and type of reactant atoms will be equal to the number and type of product atoms. The number of atoms and the type of atoms that you start with, you have to have those same type of atoms and the same number of atoms when the reaction is over. So what is a coefficient? A coefficient is a whole number that is placed in front of a chemical formula. It tells you how many, right? So for example, you might have 2 in front of an H2O. So this is telling you that you have 2 water molecules. If you have 7 in front of Fe, that's telling you that you have 7 iron atoms. So both of these numbers are considered to be coefficients. How do you determine the coefficients of a chemical reaction? Well, to figure out the coefficients of a chemical reaction, it is a bit of trial and error, right? It is a bit of trial and error, and you will have to, there are some methodical ways of doing it. We're going to approach it from a take inventory on the reactant and product side of the equation, and we are going to apply coefficients until the equation is balanced. So that sounds a little vague, but let's see what this might look like. Okay, so the first thing I really recommend that you do is find the arrow and draw a line, right? So that's separating your reactant side from your product side. I'll then recommend that you sort of make a list. Take inventory. What do you have on this side? Well, right now you have 1 nitrogen and you have iodines, but you have 3 of them. Okay, so you're starting with 1 nitrogen and 3 iodines. Over here on the right side, we have nitrogens, 2 in this molecule, and then we have 2 iodines over here. So this very much does not match up. So let's start with, you have to really, another piece of advice that I'll give you is work with one element at a time. Work with one element at a time. So I'm going to look at nitrogen, and I see that I have 1 nitrogen here and 2 nitrogens here. So for me to have 2 nitrogens represented on the reactant side, I have to put a 2 in front of the Ni3. And what that's going to do is that's going to change my inventory. So now I'm going to have 2 nitrogens, and I'm going to have 2 times 3. I'm going to have 6 iodines. Right? So I'm looking right now that my 2 nitrogens are the same, but my iodines are not. Okay, so now let's take a look at those iodines. I only have 2 on the right, but I have 6 on the left. So that means what number can I put here to multiply by 2 in order to get to 6? And if you said 3, you're correct, right? So this 3 is only applied to this iodine, so now I'm going to have a total of 6. And I see that each one of my elements is now balanced. I did not put a number here because it's implied that I only need 1 of them. So you can put a 1 there, but you don't have to. I'm going to put the 1 there just for emphasis to let you realize that it's intentional, that it's meant to be 1. It's not that I forgot it. So that would be your balanced equation. Let's take a look at another example. Our next example here, the first thing I would ask you to do is to separate your reactants from your products. On the left side, I have 1 aluminum, and I have over here, I have 2 chlorines. Okay. Over here on the product side, I have 1 aluminum and I have 3 chlorines. So when I start this, I see that my aluminums are already balanced, but my chlorines are not. So what do I need to do? I can't multiply something by 2 to get 3. This is sometimes where you might want to use what's called the least common multiple. Basically, if you multiply these two numbers, right, you're going to get 6. So what can I multiply this by to get 6? And if you answered 3, you'd be right. So 3 times 2 is going to give me 6. What can I multiply this by in order to get 6? Well, if you said 2, you'd be correct. That'd give you 6 chlorines, right? So while I did this, the chlorines are now matched, but the aluminums are not, because when I did this 2, coefficient of 2 in front of the aluminum, I now have 2. But that's an easy fix over here, because aluminum is all by itself, so all I need to do is put a 2 in front of the aluminum, and I see now that everything is balanced. So there's your balanced equation. Let's take a look at number 3. We're going to put a line down the middle, separating our reactants from our products. Right here, I have hydrogen, and I have 2 of those. And the oxygen, I have 1 of those. Over here, I have sodium, I have 1 of those. In this formula, I have sodium, 1, oxygen, 1, hydrogen, 1. So I'm making a list of each of the individual elements, and I'm counting how many I have under each formula. So this formula, it's hydrogen, and there are 2 of them. So let's take a look one element at a time. I'm going to start back. I'm going to try to be methodical as possible. I'm going to start at the left. I'm going to look at one element and just focus on that one element. Hydrogen 2, but I have this one right here. Okay, so total hydrogens are 3. So that's an awkward place to start. I think that's where we're going to have to start, because oxygen 1, sodium 1, sodium 1. So we're going to have to dive in and battle this hydrogen problem. So I have an odd number of hydrogens here. I definitely need more hydrogens on this side. I have to multiply this by 2. I can't multiply by anything less, like a fraction. I can't multiply by 1.5 or anything like that. So if I multiply this water molecule by 2, I have to distribute that through each of the individual atoms. That's going to give me 4 hydrogens and 2 oxygens. Okay, that didn't really fix anything, but let's see what that impact is. Again, I'm only really looking at the effect of hydrogen. So if I have 4 total hydrogens here, and 2 plus 1 here, if I put a 2 in front of the sodium hydroxide, that's going to give me 2 hydrogens, which is going to be nice, but remember, we have to see what the impact is through this entire molecule. So that's going to double my oxygens and my sodiums. Okay, I'm going to revisit the hydrogen again just to make sure I'm good. Hydrogen 4 on the left, hydrogen 4 on the right. We're adding those 2 together because of that plus sign. Oxygens, I now have 2 on the left and 2 on the right. Sodiums, I have only 1 on the left and 2 on the right, but that's an easy fix. If I put a 2 there, that's going to make everything work. I did not have to do anything to that hydrogen, so that's just a 1, and there we have our balanced equation. Let's take a look at number 4. We're going to divide our reactants from our products, and we're going to take a look at our first chemical formula, and we're going to do that inventory. PB, I have 1 of them. N, I have 2 of them. This 2 outside the parentheses distributes to all of the subscripts inside, so that's 2 nitrogens. And oxygens, I've got 6. 3 times 2 is 6. Ki, I've got 1 K and 1 iodine. KNO3, I've got 1 K, 1 N, and 3 oxygens. Over here in this molecule, I've got 1 PB, and I've got 1 iodine. Okay, so now that I've done my inventory, I'm going to go back, and I'm going to be methodical. I'm going to look at each element one at a time and just see what happens. So PB, I have 1 on the left, 1 on the right, so that's good. Nitrogens. I'm going back to the start, and I'm going to look at each element methodically. So the next element I see here after lead is nitrogen. I've got 2 on the left. I have only 1 on the right. So I need 2 of those. So I'm going to put a 2 in front of the KNO3, and I'm going to double everything that I had in that inventory. So 2 Ks, 2 Ns, and 6 Os. And now I see that my nitrogens are fixed. My PBs are still good. My Ns are now good. Let's see, how nice. Oxygen 6, oxygen 6. So that fixing the nitrogen fixed the oxygen. So these 3 elements are taken care of. Now let's take a look at K and I. K, I have only 1 on the left side, but I have 2 on the right, so I need to put a 2 in front of the Ki and distribute that through my inventory. So 2 Ks, 2 Is. Okay. And now I realize I made a mistake. So 2 Ks, 2 Ks, 2 iodines. I have here that I had 1 iodine, but I actually had 2. So that was a mistake. I didn't do that inventory correctly. So this actually, I believe, if I double check, 1 PB, 1 PB, 2 Ns, 2 Ns, 6 Os, 6 Os, 2 Ks, 2 iodines. So we're good. So this is 1, 2, 2, 1. All right, last one. CH4. I've got 1 carbon, 4 hydrogens. Under O2, I've got 2 oxygens. Under the water, I've got 2 hydrogens and 1 oxygen. Under the CO2, I have 1 carbon and 2 oxygens. Okay, so I've done my inventory. Now, looking at these elements one at a time. 1 carbon, 1 carbon. 4 hydrogens, 2 hydrogens. I'm going to double, put a coefficient of 2 in front of the water. I'm going to see the effect on my inventory. That's a 4. I'm going to double the 2 to a 4 and the 1 to a 2. So, going back, 1 carbon, 4 hydrogens. Now let's take a look at the oxygens. I've only got 2 on the left, and on the right, oxygen's in 2 places. So 2 and 2 together is 4. I need a total of 4 on this side. That's an easy fix. I can put a 2 in front of the O2, and that'll give me 4 oxygens. So this equation balances this way. All right, you will come across some trickier equations in the practice that you're going to work on, but this gives you a start, and it allows you to respect the law of conservation of matter by using coefficients. They must always be whole numbers. And another thing that you should add into this is that the balanced equation must be the lowest whole number ratio. So if you end up with, let's say you tried to balance this equation here, and let's say you came up with 4, 2, and 6, right? 4, 2, and 6 are just multiples of 2, 1, and 3. And so while this does mathematically work, you would need to reduce it down to the lowest whole number ratio in order to be considered a correctly balanced equation. All right, that's it for this lesson. We'll see you back in the classroom.